Hi, today we'll be looking at interior angles. Here's today's FLT. Given properties of interior angles of polygons, I will be able to find missing angle measures. Let's start off by looking at interior angles of triangles. So first off, what are interior angles? An interior angle is just an angle that's inside of a shape. And a triangle would have 3 interior angles as marked. A quadrilateral would have 4 interior angles. And a pentagon would have 5 interior angles. And the triangle sum theorem tells us that the sum of the angle measures of a triangle is 180 degrees. So for any triangle, the interior angles add up to 180 degrees. So let's use this theorem to solve some examples. Here's our first example. We are asked to solve for x in the triangle below. So in your notes, try to sketch this triangle as best as possible. So based on the triangle sum theorem, we know that these 3 interior angles are going to add to 180 degrees. So the sum of these 3 angles will equal 180 degrees. And let's simplify this. X degrees plus 30 plus 102 is 132 degrees equals 180 degrees. To solve for x, we subtract by 132 degrees on both sides. We solve for x and find that x equals 180 minus 132, which is 48 degrees. So we use the fact that the interior angles of a triangle add up to 180 degrees to solve for the missing angle measure x. Here's our second example. Again, we are asked to solve for x. I know that the 3 interior angles, are going to add to 180 degrees. So 9x minus 3 degrees plus 39 degrees plus 90 degrees, that right angle, equals 180 degrees. Now let's simplify this little by little. So I'm going to leave 9x degrees by itself, minus 3 degrees. 39 plus 90 is 129. So 129 degrees. And then in the next step, let's combine the negative 3 degrees plus 129 degrees. That's going to be plus 126 degrees. And our next step is to subtract both sides by 126 degrees. We're trying to isolate the x. We have 9x degrees equals 54 degrees. Divide by 9 on both sides, and we find that x equals 6. And you can always check your work by plugging this x value back into the original equation and making sure that the 3 angles do add up to 180 degrees. So this example is a little bit different because we actually have to draw out the triangle. And I wanted to walk through an example like this because you'll be seeing similar problems on Delta Math. So let me read it aloud first. In triangle GHI, the measure of angle G equals 8x plus 14 degrees. The measure of angle H equals 3x minus 6 degrees. And the measure of angle I equals x plus 16 degrees. and we are going to find the measure of angle G. So first things first, let's draw out triangle GHI. So here's just a random triangle. You don't have to draw it to scale. And I'm going to label it GHI. And we're given the angle measures for each angle. So I know that the measure of angle G is 8x plus 14 degrees. And the measure of angle H is 3x minus 6 degrees. And our third interior angle, the measure of angle I, is x plus 16 degrees. And we know that these three interior angles will sum to 180 degrees. So I know that the measure of angle G plus the measure of angle H plus the measure of angle I equals 180 degrees. And we're given the angle measures. So 8x plus 14 degrees plus 3x minus 6 degrees plus x plus 16 degrees equals 180 degrees. And I like to color code just so it's a little bit easier to see. Alright, so I have this equation, and first of all, let's start solving for x. Let's solve for that unknown value, and we're going to do this by combining like terms. So 8x plus 3x plus x is 12x, and then 14 minus 6 plus 16, what would this equal? 24 degrees equals 180 degrees. So we've combined like terms, and let's keep going to solve for x. We subtract both sides by 24 degrees, and we're left with 12x degrees equals, let's see, 180 minus 24 equals 156 degrees. Divide both sides by 12, and we find that x equals 13. Are we done here? What does the problem ask us to find? Notice we have to find the measure of angle G, so we're not quite done yet. So we just found that x equals 13, but we have to find the measure of angle G, which is 8x plus 14 degrees. We just solved for x, so let's replace that. 8 times 13 plus 14 degrees, and 8 times 13 is 104 plus 14 degrees. 104 plus 14 is 118 degrees. So the measure of angle G is 118 degrees. So in this example, we weren't given a triangle diagram. We actually had to draw it out ourselves. And the important step there is to correctly label each angle. After that, we solved for x, and we weren't done there yet. We used that x value to find the measure of angle G. Next, let's look at interior angles of polygons. So let's start off with a little exploration. Here I have 5 different types of polygons. I have a triangle, quadrilateral, pentagon, hexagon, and an octagon. And what we're going to do is see how many triangles are in each polygon. What I'm going to do is start at one point of the polygon and draw diagonals to see how many triangles I can create. So for example, for the quadrilateral, I can create two triangles by drawing that diagonal. And for the pentagon, if I draw out diagonals, I've created three triangles. So go ahead and try drawing out the diagonals for the hexagon and octagon to see how many triangles you get for each polygon. And then press play when you're ready. For the hexagon, let's see, I was able to find 4 triangles. And for the octagon, I got a total of 6 triangles. So let's write that out. For the triangle, obviously there's only one triangle. For the quadrilateral, we found 2 triangles. And then for the pentagon, we found 3 triangles. For the hexagon, we found 4 triangles. And lastly, for the octagon, we found 6 triangles. So let's summarize our findings in a table. So here I created a table. Go ahead and pause the video so that you can create a similar table in your notes. I have the 5 different polygons we looked at: the triangle, quadrilateral, pentagon, hexagon, and octagon. In the other columns, I will write the number of sides of the polygon and the number of triangles we found. And based on that, we'll find the sum of the interior angles of each polygon. So a triangle has 3 sides, quadrilateral 4, pentagon 5 sides, hexagon 6 sides, and octagon has 8 sides. And let's write in the number of triangles we found for each polygon. So for example, for the hexagon, we found 4 triangles. Okay, and next, we're going to find the sum of interior angles based on the number of triangles we found. We know that the interior angles of a triangle equal 180 degrees. So it's going to be 180 degrees times however many triangles we found in that polygon. So in a triangle, there's only, one triangle. So 1 times 180 degrees equals 180 degrees. In a quadrilateral, there were 2 triangles, and 2 times 180 degrees is 360 degrees. The sum of interior angles of a quadrilateral is 360 degrees. For a pentagon, there were 3 triangles, so 3 times 180 degrees equals 540 degrees. The interior angles of a pentagon sum to 540 degrees. Using the same idea, go ahead and find the sum of interior angles of hexagons and octagons, and press play when you're ready to compare answers. So the sum of the interior angles of a hexagon is 720 degrees, and the sum of interior angles of an octagon is 1080 degrees. We're going to derive a formula for this. So what do you notice about the number of sides and the number of triangles? Well, if we set the number of sides to n, I notice that the number of triangles in that polygon is just n minus 2. We're going to use this to write out a generic formula to find the interior angles of any polygon. We can find the sum of the interior angles of a polygon by multiplying n minus 2 by 180 degrees. So basically, it's the number of triangles in the polygon times 180 degrees. And this is actually called the polygon angle sum theorem, which tells us that the sum of the interior angles of a polygon with n sides is n minus 2 times 180 degrees. And we were able to derive this using the table from earlier where we looked at different types of polygons. So let's use the polygon angle sum theorem to solve for this example. So here we are asked to solve for x. We have a nonagon, which is a polygon with 9 sides. First off, let's figure out the sum of the interior angles of this nonagon. So we know that n equals 9 because there are 9 sides. And we can find the sum of interior angles by solving n minus 2 times 180 degrees, which in this case is 9 minus 2 times 180 degrees. And 9 minus 2 is 7, so we're simplifying step by step. And that equals 1,260 degrees. So by using the polygon sum theorem, we were able to find out that the sum of the interior angles of a nonagon is 1,260 degrees. Now let's solve for x. So we can solve for x by adding all 9 angles together and then setting it equal to 1,260 degrees. Make sure you're correctly writing down each angle measure. I would recommend double checking after you write it down. And next, let's simplify this equation by adding up the angle measures. Feel free to use a calculator. So we add the angle measures together and get 1,102 degrees plus x degrees equals 1,260 degrees. To solve for x, I subtract 1,102 degrees on both sides, and I find that x equals 158 degrees. And you can check your work by making sure that all 9 angles in total add up to 1,260 degrees. Let's look at one more example. We're going to solve for x in this given polygon. This polygon is a pentagon with 3 right angles and 2 unknown angle measures. So n equals 5 since there are 5 sides. So we're going to use the polygon angle sum theorem to find the sum of the interior angles of this polygon. And let me know if you have any questions about these steps right here. So we find that the sum of interior angles of this polygon is 540 degrees. That means that x degrees plus x degrees plus the 3 right angles, so 90 degrees plus 90 degrees plus 90 degrees equals 540 degrees. And let's simplify this by combining like terms. I get that 2x degrees plus 270 degrees equals 540 degrees. Next, I'm going to subtract by 270 degrees on both sides. This part cancels out, and we're left with 2x degrees equals 270 degrees. Next, we divide both sides by 2, and we've solved for x. X equals 135 degrees. So in this case, we use the polygon angle sum theorem to find the sum of the interior angles of a pentagon. So as a quick review for today's lesson, the sum of the interior angles of a triangle is 180 degrees. And the polygon angle sum theorem states that the sum of the interior angles of a polygon with n sides is n minus 2 times 180 degrees. Great work today, and please remember to submit your notes on Canvas.